we are talking about dynamic system. So this one we are talking. Okay. Okay. So, okay, this one is about dynamic system. Okay, now the main reference. Is a book, System Dynamic. Okay, System Dynamic by William G. Palm. Okay, this one, second edition. Okay, and this one is marking. Okay, marking, we have a small quiz. At the end of each lecture. Okay, and then we have homework. Okay, and then we have quiz or quizzes and lecture note. I will ask you to upload your lecture note. Not every time, but I will just ask you randomly, maybe at today or maybe next week. I will just please your handwriting, right? And then you have laboratory. You have 6 modules. Okay, and then you have first midterm and second midterm. Okay, this one is 35%. This one is 35%, and this one is 20%. Okay, this one total. This one total is 10%. Okay, so the total of this one is 100%. Okay, and I will announce the final marking, the final score, the ABC before final exam. So before this one, you already ABC you get, then you can attend final exam. If you attend final exam, then this one will be 30 and still 10%. So this one total 100%. This one is also 100%. If your final exam, then your marking there, the marking I announced before you attend final exam will be, if you attend final exam, then the maximum score can change maximum to grade. Okay, so if initially your marking is say BC and you attend final exam, then maximum become B, become AB. You cannot get A. But if this one, if you have, for example, B, and you mean bad final exam, then minimum C. 2 grade up or down. Okay, and why I give you small quiz? Because usually during online course, student just join the lecture and then go to sleep. Okay, and will be difficult for you to follow if you don't understand every lecture. Okay, you don't follow the lecture, and then before midterm, you try to watch my video. It will be very difficult. That's why I ask you to do small quiz at the end of every lecture. Okay, any question? Ada yang kamu mau tanyakan? Silakan. Ya, jadi kamu nanti ada small quiz di akhir tiap kuliah. Ada PR, ada quiz. Jadi sebelum UTS itu 50% materinya saya pakai quiz supaya kamu mencicil belajar. Kira-kira gitu. Lalu saya juga akan minta Anda untuk upload catatan Anda yang berupa tulisan tangan, bukan print screen dari tulisan saya. Ya, tidak setiap kali pertemuan, tapi saya akan secara acak akan diupload, kira-kira begitu. Ya, kemudian Anda punya praktikum. Praktikumnya online semua karena menggunakan MATLAB. Ya, Anda harus install MATLAB tuh. Tapi di ITB sudah ada MATLAB yang online. Ya, jadi kamu bisa mengerun itu dari internet. Ya, kemudian kita akan punya UTS 1, UTS 2, dan UAS. Nilai akan saya umumkan sebelum UAS. Jadi sebelum UAS nilai akan keluar di sini. Hampir semua mahasiswa akan tidak ikut UAS. Yang nilainya baik tentunya. Tapi kalau nilainya Anda nggak puas, Anda bisa ikut UAS. Kalau Anda ikut UAS, maka nilai UTS 1 bobotnya saya ubah jadi 17,5, UTS 2 17,5, jadi UAS-nya jadi 35%. Oke ya, jelas. Ada yang kamu mau tanyakan? Is it clear? Any question? Okay, if you have no question, I continue. Topic covered in this lecture. Topic. Topic discussed in this lecture is equation. Okay, equation linear, equation and curve fitting. This one appear in chapter 1 of Palm book. Okay, then we will return to Laplace transform. Laplace transform for solving differential equation. Okay, and then transfer function. Okay, and block diagram simplification. And then this one, dynamic system. Mechanical. Mechanical. Electric. Thermal and fluid. Just a little bit. Okay, and then we will discuss about Nyquist diagram. Oh, sorry, Bode diagram, sorry. Bode diagram. Bode diagram and frequency response function. Okay, and then state space. And simulation. Okay, I think this one is chapter 8. I think. Yeah, this one is chapter 8. Mechanical. Is chapter 4. This one is chapter 4. This one is chapter 6. Okay, and this one is actually chapter 4. Sorry, no. State variable 5. Okay, I think this one is the coverage with this one, until mechanical, I think, is the material, is a subject of UTS1. This one is UTS2. Any question? Any question? Okay, now I want to ask, bring your okay, so this one is the topic cover in this lecture. Any question? Ada yang mau bertanya, silakan. Yang mau bertanya? Oke, kalau kamu sudah, saya teruskan tentang linearisasi. Oke, linearization of nonlinear function. Oh. Okay. To do this one, you have to remember what Taylor series. Taylor series. Okay. Taylor series says that if you have fx, then this one will be the same with fa plus f dash e divided by 1 factorial, right? Multiply by x minus a plus the second derivative with respect, this one is second factorial multiplied by x minus a square, etc. Okay, this one is actually Taylor series. We will use this one to approximate nonlinear function. Okay, so this one, what we want to use. Okay, this one, for example, we have function, this one. Okay. This one is X, capital X, not small x, capital X. And this one is Y, capital Y, which is the same with function of X. Right? You have non-linear curve. For example, this one, the curve is something like this one. Right? We want to linearize around x0. This one must be okay, around x0. Okay, so this one x0 around this point we want to linearize. So this one must be y0, which is the same with f x0, of course. Okay, and from here I want to make another coordinate. This one as small e, and this one is another one, which is y. Okay, now look at this one. From x, if I move from here to this point, okay, suppose this one is x1, right? So from here to here is small x, right? Now we know that from this one, this line, okay, this one is linear function, y as a function of, I would say this one is a function of suppose this one is gx. Okay, this one is delta. You know that the slope of this one is the slope, okay, can be calculated from the derivative, or you can say something like this, one. F, capital F, x1 is equal to F, right, x0 plus small x. And this one is the same with F x0. Okay. Based on Taylor, we approximate only one term, then this one will be the same with df divided by dx, right? Evaluated at x0, okay, multiply by x1 minus x0. Okay, we use only the first term. Okay, so f x1 is equal to fx0 plus df over dx evaluated at x0 multiplied by x1 minus x0. And this one will be the same with f x1 minus f x0. Okay, move this term to the right hand side. So we have fx1 minus fx0 is equal to df over dx. Okay, evaluated at x0. Okay, multiply by x1 minus x0. Right? Now look at this one. This one minus this one. Right? Look at this one. fx1, this one. Okay. If I draw the line from here to here, this one is of course y1, where y1 is equal to f calculated at x1. Right? So delta, even this one is, so this one will be the same with y, which is equal to df derived with respect to, okay, evaluated at a linear point, at operating point, multiplied by this one minus this one is x. So this one minus this one is x. This one minus this one is y. So this one multiplied by x. Okay. So this one what we have here. The linearity of nonlinear function around x0. Okay. If this one is y, remember y is equal to y1 minus y0. Right? So if you want to, you can say that y1 is equal to y0 plus small y, where small y is calculated. Any question? Any question? Ya kan, silakan.
Permisi Pak,
Ya.
bertanya nggak apa-apa dalam bahasa.
Halo, ya.
Berarti kalau dalam penggunaan direct Taylor di sini itu hanya sampai yang turunan pertama ya Pak?
Iya, kita karena nanti turunan kedua terlalu rumit, jadi kita turunan pertama aja. Ya, turunan pertama aja, kadang-kadang kita udah pusing. Tapi kita mencoba untuk menyederhanakan. Kan gini, nanti kamu berhubungan dengan persamaan diferensial. Dan di dalam persamaan diferensial itu kadang-kadang ada suku tidak linier. Berarti kamu berhubungan dengan non-linear differential equation. Non-linear differential equation itu jawabannya sulit. Susah diselesaikan. Bisa diselesaikan, tapi sifatnya adalah numerik. Nah, kelemahan dari jawaban numerik, kita tidak bisa memprediksi lebih jauh lagi. Kalau sistemnya seperti ini, hasilnya seperti itu. Kalau angkanya saya rubah, hasilnya seperti apa? Kita nggak tahu. Karena itu kita lebih suka mempelajari karakteristik sistem linier, bukan sistem tak linier. Ada yang kamu mau tanyakan lagi? Silakan.
Terima kasih, Pak.
Oke. Okay, I give you example. This one. Example. Okay. Y is a function of H. In this case, is equal to H. A linearize okay. Linear equation. Sorry. Equal to and equation. Okay. Answer. Okay. For A. Around okay, so what we have here is y is equal to df dx, right? Evaluated at x0 multiplied by h, right? So in this case, look at this one. Okay, this one is the same with h power 0.5, right? So the derivation of f with respect to x, maybe I have to write here. Okay, now this one, okay, df over dh will be the same with 0.5 h power minus 0.5, right? If you have this one, x power 3, then dy over dx will be the same with 3 multiplied by x, 3 minus 1, right? So this one is 3x power 2. Okay, now this one is power 0.5. Look at this one. This one. So 0.5 appear here, and on top is 0.5 minus 1. Okay, so this one becomes 0.5 h power minus 0.5. And this one is the same with is, sorry, 1/2. Okay, and this one become 1 over h power 0.5. It means that this one will be the same with 1 divided by 2 multiplied by square root of h. Okay, now we want to calculate this one divided by dh. Okay, evaluate it at h equal to h0, which is the same with 3. So this one become 1 over 2 square root of h0. And h0, sorry, not 3, but 9. 9. Okay, so this one is 1 over 2 multiplied by square root of 9 is 3. So this one is 6. Therefore, the linear equation round h0, which is the same with 9, then become y equal to 1 over 6 multiplied by h. Okay, this one is a linear equation. So this one is a linear equation. This one is A. We get linear equation, which is y equal to 1 over 6 multiplied by small h. Okay, now B. B, you can calculate for h equal to 9.2, then using non-linear equation, then you have y, which is the same with square root of 9.2, which is the same with, let me calculate. Okay. Okay, square root of 9.2 is equal to 3.031. Okay, now using linear equation. Okay, h is equal to 9.2, right? While h0 is 9. It means that h, small h, is equal to h minus h0, which is the same with 9.2 minus 9, you get 0.2. Right? Then based on linear equation, you find that y is equal to 1/6 of h. So this one is 1/6 multiplied by 0.2 is equal to, so 0.2 divided by 6, you have 0.0333. Right? But small y is equal to y minus y0 is equal to 0.0333. Right? But we already calculate this one, y0. Look at this one, which is the same with 3. So this one is equal to 3. Therefore, y will be the same with 3 plus 0.0333 is equal to 3.033. Please compare this one and this one. The above one is often, so this one is often using non-linear equation. This one is often using non-linear equation, while this one is often from linear equation. Any question? Ada yang kamu mau tanyakan? Silakan.
Ingin bertanya, Pak.
Ya, silakan.
Berarti saat kita mengatakan linearization itu cukup sampai kita menemukan ekspresi Y sama dengan 1/6H jadinya, Pak. Tidak perlu kita hubungkan ke Y dikurang Y0-nya, Pak.
Tergantung. Kalau pertanyaannya cuma carilah persamaan linearnya, ya itulah Y sama dengan 1/6H, itulah persamaan linearnya. Hati-hati, tolong perhatikan baik-baik, buka mata besar-besar. Ya, saya udah memberikan contoh ke Anda. Apa yang harus Anda perhatikan? Ini Y besar. Ini Y besar. Ini Y kecil nih, persamaan linear ini Y kecil. Beda itu artinya. Lalu ini adalah H besar nih. Ini H kecil. Berarti nggak? Jangan campur aduk, bahkan di buku pun campur aduk. Jadi yang atas itu ditulis Y kecil sebagai fungsi H kecil. Yang bawah Y kecil sama dengan 1/6 H kecil. Wah, kacau kalau begitu. Kita bicara dua koordinat yang berbeda. Nanti kamu baca buku palm kamu. Ini koordinatnya berbeda nih, lihat ini. Yang satu itu koordinat absolut. Nah, jadi kalau Anda lihat di sini, ini adalah koordinat absolut. Ini koordinat absolut. X besar, Y besar. Ini koordinat relatif. Ya, jangan dua-duanya kamu campur adukan. Kacau itu kalau kamu gitu nanti. Jadi itu kita mengatakan hal yang berbeda. X besar dan X kecil itu beda. X besar itu koordinat absolut. Artinya ya diukur dari X0, Y0. Absolut. Sedangkan X kecil, Y kecil itu relatif terhadap titik operasi kita. Ya. Jadi jangan bingung. Saya dulu baca juga bingung itu maksudnya. Kenapa kok bisa sama-sama kecil? Padahal itu maksudnya beda. Beda koordinat. Oke, jadi kalau kamu cuma ditanya linearisasi ya sampai di situ aja. Tapi mungkin kamu akan disuruh membandingkan. Oke, now let's talk about this one.
Terima kasih banyak, Pak.
How if C for H is equal to 10. Then using non-linear equation, then Y is equal to square root of 10, which is the same with square root of 10. What you have is 3.1623. Okay. Now using non-linear and using linear. Okay, because H is equal to 9 and H0 is equal to, H is equal to 10, right? While H0 equal to 9, it means that H is equal to 1. Okay, and then Y is equal to 1 over 6 multiplied by 1 is equal to 1 divided by 6 is equal to 0.167. Okay, so Y is equal to Y0 plus Y, which is the same with 3 plus 0.1667. And what you have is 3.1667. Please compare this one and this one. This one, compare with this one. Okay, what is the conclusion? The conclusion is linear equation is just the same. However, if you move further away from linearization point, then the result become way different, become more and more different. Okay. Any question? Any question? Okay, now if you have no question, I will continue with the second topic. Both of these topics are available in chapter 1 of Palm's book. So what I'm discussing is available in Palm book chapter 1. Okay, now I want to discuss about curve fitting. Or you say linear regression. Okay, I give you simple example, simple practical example. Okay, for example, we have mass here. Okay, we have a mass and we will apply force. Apply force. Okay, the mass is M and due to force, then we have acceleration E. Okay, we have friction F, which we don't know. So we suppose we don't M and how we can measure. Okay, so assume that we don't know the mass and we don't know the friction. Okay, now what we do is something like this one. Okay, what we do is something like this one. Okay, we do experiment. We apply force and we measure acceleration. By measuring the force, we apply known force and measure the acceleration. By measuring force and acceleration, we can identify M and L. Jadi ini ya massa dan gaya geseknya tidak diketahui. Itu ceritanya ya. Lalu kita mau melakukan eksperimen. Caranya gimana? Caranya adalah kita kasih gaya yang diketahui besarnya, lalu kita ukur percepatannya. Kan begitu ya. Oke. Nah, sekarang ini hukum yang berlaku adalah seperti ini. Sigma F. So, this one, the second law of Newton, sigma F is equal to M multiplied by E. Right? And then what you do? This one is equal to force minus friction is equal to M multiplied by E. Oke. Nah, sekarang kan kita mengembangkan metode. Kalau kita mengembangkan metode, ya, kita mengujinya gimana? mengujinya kita uji dengan sesuatu yang kita ketahui tapi kita pura-pura nggak tahu dulu. Ngerti nggak ceritanya? Jadi ini sebetulnya kita nggak tahu. Kasusnya kita nggak tahu. Nanti kita pakai dalam praktek itu kita nggak tahu. Masanya nggak tahu. Gesekannya nggak tahu. Tapi kita sekarang mau mengembangkan metode. Bagaimana kita mengetahui M dan F-nya gimana. Karena itu saya buat contoh di mana M dan F-nya diketahui. Ya. For M equal to 2 kilogram and F equal to 1 Newton, right? Then F minus 1 is equal to 2 multiplied by E, or E is equal to 0.5, right? 0.5 F minus 0.5. Okay, now look at this one. Look at this one. We apply force. For example, we want to apply force. This one is, suppose this one, 3 Newton. And then we apply 5 Newton. And then we apply 7 Newton. And then we apply 9 Newton. Okay. Then this one is theoretical. Of course, if you substitute this one, look at this one. 1.5 minus 0.5 is 1, right? Okay. While this one will be 2. Okay. While this one will be 3.5 minus 0.5 is 3, right? This one theoretically 3. 4.5 minus 0.5 is 4. This one is theory. You cannot obtain this one in practice. What you measure in practice, measurement, most likely what you have is something like this one, 0.8, 2.2, okay, 3.1, and this one, 3.9. Okay, so what you have is this one, and this one, obtained from experiment. Okay. Now, look at this equation, right? If you plot the acceleration from this graph, okay, if you plot something like this one is the amount of force you apply, and then this one is the acceleration you measure, then this one, most likely, this one is something like this one. Not located in the straight line. Okay, so this one, if you connect this one directly, what you have is something like this one. Okay, but what we want to do is to do least square. The baseline not necessarily pass through all points, but the distance to the experiment point is as small as possible. So we want to find a line, for example, something like this one. Okay, with equation, for example, this one is y, or y is equal to mx plus b. In our case, this one, okay, if you derive from here, f a is equal to 1 over m f, right, minus f divided by n. If we can derive the curve fit of linear equation, something like this one, right? M, saya itu menurunkannya M, N ya. Okay, so this one, okay. I want to change the notation, M x plus b, but in your book, they are using mx plus b. So this one equivalent with this one in our case. This one is equivalent to this one. This one I can say this one is this one m is mass, but in this one is m1. Okay, something like this one. And this one is equal to this one. Okay, let's try to derive the equation, okay, to obtain the best straight line. Not necessarily pass through all the point, because if you do that, then the line is not linear. Okay, but our equation, this one, shows that the line must be linear. Ada yang kamu mau tanyakan? Ada yang kamu mau tanyakan? Loh, ada yang kamu mau tanyakan? Iya, kita turunkan aja persamaannya kalau Anda nggak mau bertanya. Oke, let's derive the curve fitting. Curve fitting of y equal to mx plus b. Okay, so this one is the experimental data. For example, this one is x, this one is y. Okay, and then you have data, something like this one. And suppose this one is the line, the best line you choose. This one with equation equal to mx plus b. Okay, this one, we call this one is x1, this one is y1. Data 1. So x1, y1. And let's assume this one data I. So xi, the height of this one is yi. Okay, so if you see this one, then look at this one. The height from here to here is the same with y, which is the same with mxi plus b. So if you substitute xi in the linear equation, you get this one. Okay, while this one from here, sorry, how can I write that? From here to here, is yi. Right? So this one, the difference between the data, this one is error. I minus mxi plus b. We have error number 2, error number 1, error number 2, error number 3, error number 4, error number 5, because we have I is equal 1, 2, 3 until as many data available. Okay, now we want to adjust the line. The line you can adjust. Okay, for example, with this one, you have to adjust so that the summation of EI minimum. But I don't like this one because sometimes AI is positive, sometimes is negative. So I don't like this one. I prefer to use this one. Okay, I write this one there. I want to minimize sum of square error. Okay, so minimize sum of square error. Okay, so J is equal to sigma I equal to 1 until n of AI square. Okay, and this case, look at this one, and this one is the summation of I 1 until n of, look at this one, yi minus mxi plus b square. Okay, you can adjust, you can choose m and b. So choose m and b so that J minimum, the sum of square error minimum. Okay, you can minimize the sum of square error occur when do J over do M is equal to 0 and do J over do B is equal to 0. So because M and B can be adjusted, okay, then we can adjust M and B. But the criteria is adjust M and B so that J, which is the sum of square error, minimum. Okay, now look at this one. Apply this one. Do J over do M is equal to 0. When you derive this equation, look at this one. This one is equation, this one, right? We want to derive this one. So this one become this one. Okay, yi minus mxi plus b power 2 move there. Remember this one, y is equal to say 3x plus 4 power 5. Then dy over dx is equal to 5. Okay, 3x plus 4 power 4 multiplied by the derivation of this function. We call it change derivative. And this one, the derivation of this one is 3. Right? So this one is also the same. We have 2 move to the front. This one become 1. But we have to derive this one. And we derive this one with respect to m, not with respect to xi. Okay, we derive that one with respect to m, then what we have is minus xi. Sorry, this one is minus xi. Xi is equal to 0. Okay, and this one, because equal to 0, you can forget about this one. Forget about minus, right? So that what you have is sigma yi minus m xi plus b multiplied by xi is equal to 0. If I multiply this one, what I have is sigma yi xi minus m, okay, sigma xi squared, okay, minus b, okay, sigma xi is equal to 0. Okay, and this one I can write it down as m sorry, m okay, this one become m. Come on. Ini tuh kadang-kadang saya terganggu. M ya, sebentar, saya harus kayaknya harus buka lagi coba. M sigma xi squared plus b sigma xi is equal to sigma yi xi. This one first equation. Okay, now we want to derive the second equation. Dou J over dou B is equal to 0. And if you do this one, what you have is 2 sigma yi minus m xi plus b power 1 Okay, we derive with respect to B. So if you derive with B, this one is minus 1. Is equal to 0. Okay. Now look at this one. This one, forget about 2. Forget about minus 1. So we have sigma yi minus m sigma xi plus, minus sigma b is equal to 0. Okay, but sigma b is actually a sigma I from 1 until 10 of b. Because b is constant, this one is just b plus b plus b plus until b as many as n. So this one is the same with n multiplied by b. Right? Therefore, this equation become m multiplied by sigma xi plus n multiplied by b is actually the same with sigma yi. And this one is equation 2. Okay. And we want to find m, this one. This one is m sigma xi squared, right? Now we want to find m and b. We have 2 simultaneous equations. Look at this one. Okay. Now, if you want to find m, then you have to cancel b. Okay. So to cancel b, look at this one. Equation 1. Equation 1. Equation 1 multiplied by n. Then you have n multiplied by m sigma xi squared plus n multiplied by b sigma xi is equal to n sigma yi xi. Okay, and equation 2 to make n b the same with that one, then you multiply this one with sigma xi. If you multiply this one with sigma xi, what you have is m multiplied by sigma xi square. Oh, sorry. Multiplied by xi multiplied by sigma xi. So sigma xi square, okay, plus n multiplied by b multiplied by sigma xi is equal to sigma yi sigma xi. Okay, then if you subtract this one, get this one, mn. So what you have is something like this one, and sigma xi squared minus sigma xi squared multiplied by m is actually the same with n sigma yi xi minus sigma yi xi. Therefore, from here, we can derive that M is actually the same with sigma and sigma yi xi minus sigma yi xi divided by n sigma xi square right? Xi, did I make mistake? This one is correct, yeah. And sigma xi square minus sigma xi square. So this one is the formula to calculate M. Similarly, you can often derive that B is equal to, what is it? Sigma yi sigma xi square minus sigma xi sigma yi xi divided by n sigma xi square minus sigma xi square. This one is the ya ini oke. Now ini tuh masih sering mengganggu. Jadi saya harus coba. Masih belum mau lagi. Okay, so this one. Pusingnya. Rumusnya luar biasa sulit ya. Enggak. Coba kita pakai. Nanti kalau saya nggak sempat, kayaknya mungkin nggak sempat, tapi saya mau tunjukkan bahwa ini perhitungannya tidak sulit. Oke, tapi sebelum itu saya tulis PR-nya dulu aja ya. Jadi ini, so this one seem difficult, but it's not. Okay, and this one is the derivation if we want to derive linear equation. Later we will derive more complicated. Okay, but before I try to calculate, I want to write down homework. Okay. One. Fine. Linear. O. E. Sorry. Ya, jadi ini ceritanya kita mau mencari koefisien drag. Jadi ceritanya supaya kita bisa mengetahui koefisien drag, maka kita tarik mobil di jalan tol. Ya, lalu kita pertahankan sehingga kecepatannya konstan. Maka yang terjadi akan terjadi persamaan semacam ini. Nih. Persamaan semacam ini. Dari persamaan ini coba kamu hubungkan dan ini. Di mana terjadi bahwa gaya tarik, jadi ini mobilnya ditarik dan pada tambang penariknya itu diletakkan sensor gaya. Jadi kamu tahu gayanya berapa. Kamu juga tahu kecepatannya berapa. Nah, pada kecepatan tertentu, ya, gayanya tertentu. Nah, ini adalah hasil eksperimennya. Dari situ kamu pengen tahu besar koefisien rolling resistance, yaitu FR ini, dan koefisien C ini. Nah, coba diperoleh ya dari hasil eksperimen. Ini 910, 1800, 1880, 3320 dan 5070. Ini udah benar. Ya, jadi kita mau mencari koefisien rolling resistance sekaligus koefisien drag. Dengan persamaan kurvit. Ini datanya. Kamu tidak bisa kalau kamu mau hubungkan satu-satu datanya, nanti tidak memenuhi persamaan fisika ini. Oke, ada yang kamu mau tanyakan, silakan. Nanti kalau udah saya terangkan sedikit cara menghitungnya. Anda harus bisa mengerjakan ini karena kadang-kadang kita harus menurunkan persamaan kurvit yang tidak tersedia di Excel maupun di mata. Jadi seolah-olah Anda perlu menurunkan persamaan COVID tersebut. Oke, ada yang kamu mau tanyakan? Yang tadi ya, sekarang yang tadi saya mau, kita punya persamaan semacam ini. Ya, untuk kasus kita yang tadi, kita punya persamaan, saya tulis dulu supaya gampang lihatnya. M itu sama dengan N sigma yi xi, right, minus sigma yi xi salah ini sebentar. Ini saya ada yang salah nih persamaannya sebentar. N minus 1 kalau gitu ya, yang atas ini. Sigma, kayaknya sih nggak salah sih. Saya yakin nggak salah, tapi kok kalau persamaannya gini, sebentar ya, saya merasa nggak salah itu. Saya tulis saja. Oke, N sigma yi xi minus sigma yi xi and sigma I square minus sigma
itu pembilangnya ini Pak.
Kenapa?
Pembilangnya itu minus sigma yi sigma xi.
Nah, itu baru benar nih. Ini kalau saya rasa juga gitu. Itu Oke. Lalu B sama dengan sigma yi sigma xi square minus sigma xi multiply by sigma yi xi divided by n sigma xi square minus sigma xi square. Okay. Now, what is our data? What is our data? Look at this one. What we have is something like this one. Right? So this one is F. And this one is A. Okay. This one is, say, 3 Newton, 5. And this one is 7. This one is 9. This one is 0.8. This one is 2.2. This one is 3.1. And this one 3.9. 3.1. And this one is 3.5. Okay. The equation, look at this one, is F minus F is equal to M multiplied by A, right? Therefore, M multiplied by A is equal to F minus F, or A is equal to 1 over M multiplied by F minus F divided by M, right? what we already derived is y is equal to, what is it? M multiplied by x plus b. So what does it mean? It means that A equivalent to y and F equivalent to x. So this one, F, is equivalent to x, and this one equivalent to y. Right? Now, to calculate this one, to calculate M, you have to know N, right? N is simple. This one is number of data. N is number of data. So it's very simple. So this one is I, right? This one is 1, 2, 3, 4. So N is equal to 4. Okay. And then what else? This one is I, and this one is yi, right? We have to calculate xi multiplied by yi, sigma xi. So sigma xi is this one. This one is sigma xi, which is the same with, what is it? 10 plus 14, 24. So this one is 24. Okay, we need this sum. Sigma yi. Sigma yi is this one. Sigma yi is equal to this one. Just add this one. This one becomes 3. Right? Sorry, this one 3. 6.1. Or this one become 7. 7 plus 3. So this one become 10. And sigma y is this one. Sigma y is this one. So this one, this one is sigma y. Okay. What else we need to calculate? Sigma I squared. So calculate this one. X I squared. 3 squared is equal to 9. 5 squared is 25. 7 squared is 49. Okay. 9 squared is 81. Okay. And this one is sigma xi squared equal to something. And that one is this one. Is this one. Come on. So this one is finished. This one is finished. Sigma xi is finished. Sigma yi is finished. Now we have to calculate sigma xi yi. So calculate xi yi. This one multiplied by this one is 2.4. 5 multiplied by this one is 11. This one multiplied by this one is 21.7. And this one multiplied by this one, and that one, you will have sigma xi yi. Okay, is equal to what? And that one is there. This one. Okay, please note that sigma, come on, sigma yi xi is not the same with sigma. Come on. Ini sebetulnya saya sudah mau beli Samsung Tab karena dia spesialis untuk nulis. Jadi pulpennya selalu muncul. Ini kadang-kadang pulpennya nggak muncul nih, bermasalah. Ini so this one is not the same with okay, share again. Okay, sigma YI is not the same with ini masih bermasalah. It's not the same with sigma YI multiply sigma XI. It's not the same. Okay, in this case, you multiply first, and then sum them up. Okay, while this one, sum first and then multiply. Okay, any question? Okay, if no question, please, Kak Nasir.